Hello friends, now going ahead with our previous video. So we calculated this descriptive statistics for the given data here. Okay, so this is our data for the concentration of the pollutant. So there was 27 samples. So for this one we calculated the descriptive statistics. So the first one, the mean is 7.5, which means the arithmetic average of the data set, and the standard error basically means how much the sample mean would vary if we have to repeat the study using new samples of the data that we have. Median is the midpoint of the data set. Mode, basically, if you see here, if it represents not applicable, so basically the not applicable here specifies when the mode cannot be computed or it does not exist because all our values occur here with the same frequency. And standard deviation basically means how much the sample mean would vary if we have to repeat a study using a new here the standard error basically means if we have to calculate like the sample mean, so the deviation is the standard deviation of the sampling distribution of the uh, statistics. So a small standard error will indicate a more precise estimate of a population parameter. So it will increase if your sample size is going to increase. So sorry, this is a repetition here. Okay, now the sample variance, it is going to measure the variability of the sample statistic from the uh, parameter or the data that we have. Kurtosis is a measure of combined weight of a distribution tails relative to the center of the distribution curve, referred to as the mean. Okay, now the kurtosis basically means the distribution will be whether plateau kurtic or lepore kurtic. Okay, so this is a kind of distribution, so the data can be tailness, or it would have outliers, or the peakedness. Okay, and then we will discuss this in detail in our next lecture. So skewness is a measure of asymmetry of a probability distribution of data sets that is lying around its mean. Okay, now the range is a simple measure of data dispersion that will be calculated by excluding the smallest value from the largest value in the data set. Now the minimum maximum we know on the data set what is there, sum also, the count basically, count, the count data is statistical data type describing the countable quantities, largest, smallest, and the confidence level basically here is represents the long proportion of times confidence interval would contain the true population parameter. For example, for instance, in a condition we have 95%, so it will specify that there is sampling process were repeated many times. Okay, and it is going to tell you the measure of precision and stability of an estimate. Okay, and also if you have 90%, 98%, so this means that 98% or 95% of intervals constructed from repeated samples will capture the true value. Now let us go ahead with another kind of exercise. For example, if we have, now here we have a sample of data, you can see. Okay, we have the wastewater treatment plant data. For example, if we have to do the correlation of this data, so what we will do, we'll simply go to the, as we discussed earlier, we will go to the data analysis tab, and then we will select the correlation. Okay, and then we will select the data, So this is our data, the array of data that we have from A to H14. So from starting from here to here we will select, and then if you want the output range to be on the same sheet or the new worksheet, and make sure you selected these. So we will click OK. So this is my correlation. So you can see here. In our later videos we will talk about what does this 1 and this mean, okay, and what are these numbers, what are the significance of these numbers. Okay, now if suppose for the same data set we are going to do the covariance, okay, so we will select the whole data, for example here, and we want that in the new worksheet. So this is again my covariance, okay. So let's stop our discussion today. So this is my covariance, and in our next videos we'll be talking in detail what does these output or the data that we got signify.